derivatives of exponential and logarithmic functions. Here we have question 6. If y equals x squared ln e power x, then dy dx equals 3x squared or x power 3 ln x power 3 or 0. Here we have two functions. We have x squared dot ln e power x, and we can rewrite ln e power x in this form: x ln e. So we have y equals x squared multiply x ln e, and ln e equals 1. So we have x squared multiply x multiply 1, which equal x power 3, and then we make the differentiation to get dy dx equals 3x squared, and the result will be letter A. We will choose letter A. Question number 2. If y equals e power x, z equals sine x, then dy dz equals, here we will use chain rule. We have y equals e power x, z equals sine x. To get dy dz, we'll make this differentiation: dy dx multiply dx dz. Again, dy dz equals dy dx multiply dx dz, or you can say it's equal dy dx divide dz dx. So dy dx equals e power x. Since y equals e power x, so dy dx equals e power x. And also since z equals sine x, so dz dx equals cosine x. And the result will be e power x divide cosine x. E power x divide cosine x, and the result will be letter D. Question number 8. If a power y equals b power x, where a and b belongs to the set of R positive, the set of positive real numbers, then dy dx equals log a over b, logarithm b to the base a, logarithm a to the base b, logarithm b over a. Here we have a power y equals b power x. It is given. Then by taking the common logarithm to both sides, what we get? We will get log a power y equals log b power x. From the properties of logarithm, we can take the power out here, and we can take x also out of the logarithm. So we have y log a equals x log b. So y divide x equals logarithm b over logarithm a. So we can write y equals x logarithm b over logarithm a, and logarithm b over logarithm a equals logarithm b to the base a. So dy dx, we'll make the derivative now. Dy dx equals the first multiply derivative of second. We have here two functions, x and log b to the base a. It is a constant. Its derivative equals 0. Plus the second multiply the derivative of the first function. So we have log b to the base a multiply the derivative of x, which equal 1. So dy dx equals logarithm b to the base a, because x multiply 0 equals 0, and the logarithm b to the base a multiply 1 equals logarithm b to the base a. Here we have if y equals e power negative x dot ln x, then dy dx equals, here also we have two functions. The first is exponential function e power negative x, and the second is logarithmic function ln x. So the first derivative equals the first function multiply the derivative of the second function. What is the derivative of ln x? The derivative of ln x is 1 over x plus the second function here multiply the derivative of the first. Derivative of e power negative x is e power negative x multiply negative 1 here. So we can take negative, we can take e power negative x as a common factor. So we write e power negative x multiply, here we have a bracket, 1 over x minus ln x. So the solution is in letter A, e power negative x multiply 1 over x minus ln x. Next question, the equation of the tangent to the curve b equals y equals b dot e power negative x over a at the point of intersection with y-axis is, here the question about the equation of the tangent to the curve. What is the equation of the curve? The equation is y equals b e power negative x over y. At a certain point, this point is the intersection point with y-axis. Okay, we have y equals b multiply e power negative x over 1. And we know that the equation of the tangent, the tangent is a straight line. So its equation will be in the form y minus y1 over x minus x1 equals m. M is the slope of the tangent. So we must calculate the slope of the tangent m and x1 and y1. x1 and y1 is a point on the curve. Actually, it is the point of tangency. So since y equals b dot e power negative x over a, then dy dx equals the first function multiply the second. The first multiplies the derivative of the second. What is the derivative of e power negative x over a? Its derivative equal the derivative of the power negative 1 over x multiply the function itself e power negative x over a plus the second function multiply the derivative of the first, and the derivative of b is 0. So the second multiplies the derivative of the first will be 0. So we simplify the solution. It will be negative b over a e power negative x over a. b multiply negative 1 over a equals negative b over a dot e power negative x over a. Now I will calculate, I will find the point of intersection of y-axis. At this point, we have x equals 0. So since x equals 0, you can substitute in this form. This form is the equation of the curve. Put x equals 0. So we have e power negative 0 over a, e power 0, e power 0, and the e power 0 equals 1, multiply b equals b. And the slope at this point when x equals 0. We have here the slope dy dx equals negative b over a dot e power negative x over a. Substituting x equals 0, what we get? Negative b over a e power 0 over a, negative 0 over a, which equals 0. So the slope equals negative b over a. Now we have the slope here equals negative b over a, and the point will be 0 and b. So the equation of the tangent who's passing through the point 0 and b, and its slope m equals negative b over a. The slope equals y minus y1, y minus b over x minus 0 equals negative b over a. And simplifying this form, we will get ay minus ab equals negative bx. It's cross multiplication. Y multiply a equals ay. Negative b multiply a equals negative ab equals negative b multiply x equals negative bx. So dividing both sides by ab here, what we get? Dividing both sides by ab. So we have ay divide ab minus ab divide ab equals negative bx over ab. A divide a equals 1. So we have y over b minus a divide a equals 1. ab divide and b divide b equals 1. So ab divide ab also equals 1, which equal b divide b equals 1. Here we have negative x over a. So the equation of the tangent is y over b plus x over a, which equal 1. Y over b. And from the right hand side, we will bring negative x over a to left hand side. It will be positive. Notice the negative sign here. So we have x over a equals negative 1. It will be positive 1. So I get this result. It is the equation of the tangent. And this is in letter D here. Next question. If f of x equals e power x gx and g of 0 equals 2, g dash of 0 equals 1, then find f dash of 0. Here, the required is to find f dash of 0. And f of x equals e power x dot gx. F of x equals e power x dot g power x. So f dash of x equals the first multiply the derivative of the second. G dash of x plus the second multiply the derivative of the first. The derivative of first function, the first of e power x is e power x itself. So f dash 0, the required here is to find f dash of 0 here. So f dash of 0 equals e power 0 multiply g dash of 0 plus g of 0 multiply e power 0. This is substituting x equals 0. and you can complete. E power 0 equals 1. G dash power 0 from the given, sorry, G dash of 0, where G dash of 0 equals 1 again, plus 2 multiply G of 0. G of 0 equals 2 from the given. Here we write it. E power 0 equals 1. 1 multiply 1 plus 2 multiply 1 equals 3. And the solution will be in letter B. Here. Next question. Question number 12.